Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is real numbers. Real numbers are combination of both rational and irrational numbers. For example, the fraction 2 by 3, negative integer -5 and square root 2 are all examples of real numbers. We may recollect the definition of rational number, which can be written in the form of P by Q, where P and Q are integers and Q not equal to 0. Similarly, irrational numbers are those which have non-terminating and non-repeating decimals. Root 2 is an example, root 3, root 5, root 7 are other examples. Another important irrational number is pi. You would have seen in your books to approximate pi by a fraction 22 by 7. Yes, the value of 22 by 7 and pi are very close. However, there is one difference between the two. 22 by 7, if we check the value in a calculator, we'll observe that the decimal part is repeating. After 6 decimals, the decimal part is repeating in the fraction 22 by 7. However, pi, it is non-terminating and non-repeating. So pi is an irrational number, whereas the fraction 22 by 7 is rational. Further, let us discuss prime numbers, composite numbers. Prime numbers have only two factors, 1 and self. For example, 2, 3, 5, 7, 11. These numbers have only two factors, the number 1 and the number itself. Composite numbers, on the other hand, have more than two factors. For example, 12 has factors 1, 2, 3, 4, 6 and 12. Every composite number can be written as a product of prime numbers. This we call it as prime factorization. For example, 30 can be written in prime factorization form as 2 into 3 into 5. Now let us discuss HCF and LCM. HCF refers to highest common factor. Multiply, here we multiply the smallest power of each common factors in the numbers. Let us take an example. We want to find HCF of 12, 24 and 144. The prime factorization of these numbers can be written as 12 as 2 square into 3, 24 as 2 cube into 3, 144 as 2 to the power 4 into 3 square. Now the common factors are 2 and 3. So we will take the smallest power here because the smallest power of each common factor. So from 2 we will take 2 square and from 3 we will take 3. Another 3 square we will not take it in HCF, and we multiply them, we get 12 as the answer. LCM refers to lowest common multiple. Here we multiply the largest power of each common factors in the numbers. Now we consider the same numbers and try to find the LCM for that. We know the prime factorization of that. Now we pick up the highest power. So we will take 2 power 4 and multiply with 3 power square. The answer is 144. This is an important formula which you must remember, that LCM of two numbers and its multiplication with the HCF of those two numbers will be the multiplication of the numbers themselves. Friends, this is a very important aspect and you should remember. Please note that this is valid only for two numbers. And if you are taking HCF or LCM for three numbers, then this particular formula cannot be used. Let us verify the above identity. Find LCM and HCF of 12 and 16 and verify above formula. So 12 equal to 2 square into 3 in prime factorization form, 16 equal to 2 power 4. So HCF will be, friends, the common factor we have to take lowest of that. So 2 is the common factor and 2 square is the lowest, so we'll get HCF as 4. To find LCM, we'll take the highest power, 2 power 4, and also we need to collect the remaining terms. This is very important. In HCF, we don't collect those. In LCM, we need to collect the remaining terms also. For example, if you have another number and it is say 2 power 3 into 5. So our answer will be 2 power 4 into 3 into 5. The balance term also need to be collected for LCM. Now let us verify this identity. LCM we got is 48, HCF is 4. We multiply these two. So and we see the product of the two numbers for which we were taking LCM and HCF. So 12 into 16. The product is 192. So this identity is verified. Now let us come to fundamental theorem of arithmetic. Here, if b is a positive number and p is a prime number, if p divides b square, then p also divides b. This particular is the fundamental theorem of arithmetic. Let us give definition of coprime numbers also, having only one common factor, which is 1. So those numbers having only one common factor as 1. Now we give few examples here. We want to show that root 5 is an irrational number. We prove this by contradiction. That is, first we assume root 5 to be rational and later prove that our assumption is wrong and root 5 is indeed irrational. So let us proceed with the solution. Let root 5 be rational. If a and b are coprime numbers, then root 5 can be written as a by b. We have assumed root 5 now as rational. So this can be equal to a by b. On cross multiplication, b root 5 is equal to a. Now squaring both terms, we get 5b square equal to a square. So what does it mean? It means a square is now divisible by 5. So from the fundamental theorem of arithmetic, a is also divisible by 5. So we can write a as a equal to 5c, where c is some integer. Now putting this a equal to 5c into this, we get 5b square equal to 5c the whole square, which is 25c square. So b square is equal to 5c square. Now b square is divisible by 5. So b is also divisible by 5 by fundamental theorem of arithmetic. So what we observe that both a and b have 5 as common factor. This contradicts that a and b are coprime, which we started with. Thus assumption that root 5 is rational is incorrect. Hence root 5 is irrational number. There are some more important facts regarding this. We see that if we add or subtract a rational and irrational number, then the resultant number is irrational. So 2 minus root 5 is irrational. 4 plus root 3 is also irrational. Similarly, if we divide or multiply a rational and irrational number, again the resultant number will be irrational. For example, 3 root 7 or 5 by root 11, they are all irrational numbers. Let us take a practice problem and try to prove that 4 root 7 is irrational. Again we'll prove it using theorem of contradiction. That is, first we say 4 by 4 into root 7 is rational and prove this assumption is incorrect. So let us start with the solution. Let 4 root 7 be rational. If a and b are coprime, then we can write as 4 root 7 equal to a by b. So root 7 will be equal to a by 4b, where a, 4 and b are integers. So root 7 is a rational number. But this is incorrect since root 7 is an irrational number. Hence 4 by 7 becomes irrational since our assumption was incorrect. Friends, with this we conclude this video. I request you to please subscribe my channel so that further videos can be posted to you without any delay. And also I request to give a thumbs up to this video. This will motivate me to make more such videos for you. Thank you very much, friends.